Hello, one. So we have another AMC 1012 problem. So this was number 23 on the 10A and number 20 for 12A. So it's an interesting question. So we have a like trapezoid A, B, C, D, and one side is smaller than the other one. Okay, and then AB is same as CD. So let's kind of go ahead and try visualizing. So I'll go with sketching that first. So what we are told, the BC is the side that is smaller, which means this has to be my BC, and then this has to be AD. So then I will go with this is A, this is B, C, and D. Okay, and then AB and CD are equal. So this guy, I mean AB and CD. Okay, so this has to be C, by the way. So that's isosceles. And then there is a point P inside of the trapezoid. PA1 is PB is 2, P is okay. So let's try something maybe somewhere there. That's PA, PB, PC. So it looks like straight line, but it's not. And then this is my point P. This is 1, 2, 3, and 4. So what we are like looking for is the ratio of the BC and AD. So this is BC, this is AD. So we are expecting something smaller than 1, which all the choice like that. But there are 4 distances, which we kind of need to use it. But if I want to try like using distance formula somehow, then I need all these 4 points, which I don't have any information about those A, B, C, Ds. But since this is isosceles, maybe using symmetry might help a bit. So for that reason, I'm going to actually put this in the current plane. So where I actually going to take this y-axis as the line of symmetry of this figure. So that is just going to be right in the middle of this trapezoid. So the reason I'm going to do that, because when I kind of label the coordinates, so I will have some symmetry going on, which will be useful. So let's call this is A comma 0. And then since the distance from this to D, the line distance, and then distance to A has to be same. So this has to be just a negative version of A, which was the main point to kind of use this right in the middle as y-axis. The x-axis doesn't probably matter, so I'll just go with the y-axis. So then if I say this is, let's say B comma C, then this point has to be just a negative version of B, but C will be the same as the y coordinates of this one. Okay, so now what? So like I'm gonna take a point P, let's call this is X comma Y. And what we are looking for the distance between B and C and A and D. So if you think about this is somewhere is origin on this axis, let's say right here, right? So then the distance from this axis to the C point C is B units. So that's also B units. So that's 2B. So we are looking for 2B over the same reasoning for AD is 2A. So this is what we are looking for. So then let's go ahead and use those like numbers 1 through 4. So if I take the distance between P and A, so that should be P A, like is gonna be 1, which is gonna be 1 square. So which I call P as X comma Y. So this is between P to this guy. So X minus negative 8. So that will be X plus A to the second power by just the distance formula, and then y minus 0, which is going to be y squared, okay, is equal to 1 squared. That's just going to be 1. And if I take the same thing with this to D, because it has also A, so that will be X minus A to the second power plus the y value of p and minus 0, which is going to be y to the second power. So that should be 16. Okay, so we have them. And then the same reason we're going to use the other 2 points. So distance between b and the p. So that should be x minus b, which is going to be x plus b square. And then y coordinates of p minus c. So that should be y minus c square. And that should be 4. And then p to c, so x minus b square plus y minus c square is equal to 3 square, which is 9. So, okay, we have 4 equation, and then we also have 4 variable, which is actually helpful to solve the system. So what I'll try is, the first 2 equation that we have has the y squares, and if I expand this and subtract this, let's say I'm gonna multiply this -1, right? And combine that equation with the second one. So I'm not gonna write these, but when you expand it, so you get x squared and a square, a square, a square, y squared, y squared. They are gonna all cancel each other. And then in this term, we'll get -2ax as a middle term, and then 2ax as a middle term, but this is gonna be multiplied by negative because I want this to be positive. So that will give us -4ax. And this is equal to 16 minus 1, which is 15. Okay, let's keep this in mind. And the same reasoning I'm going to do. I'm going to multiply this by -1 and then combine with the second equation, right? So if I do that, this entire parentheses will be cancel each other. So, and then the x squared and b squared will cancel each other. So you get -2bx, positive 2bx, but this is going to be multiplied by negative. So you will get -4, like bx is equal to 9 minus 4, which is going to be 5. So now we have these 2 equations. We want to find the b over a. So this has a, this has b, and then a, these 2 has x's as well. So I'm going to rewrite this right here. So that should be -4bx is equal to 5. So if I divide these equation, these guys will be gone, and then you got b over a is equal to 5 over 15, which is just 1 over 3. So which is my choice B? So this was number like 23 or 20 on 10A and 12A, which meant to be really challenging. But when you use the Coordbash, as you see, it was actually way easier than a lot of other questions. So I hope that was useful. So I just want to remind the Coordbash is sometimes our best approach. So even though this question can be done a lot of different ways, but the Coordbash in this case was a lot helpful. Anyway, I'll see you in the next video.